Hi. Okay, I want to do a bit of an update. I've made some changes to the demo that we do for the BDA days. So this really is a video for any of the BDA instructors on the demo. What I want to do is basically run through what you would need if you were to start off with no services and no application running in Bluemix. If you have the heart monitor, if you have the Android application, what you would need to actually get it set up with NodeRed, the Internet of Things service, -DB, and what's the final bit? Yeah, Shiny, which is using the R HRV package in R. Okay. So firstly, let's go to let's start off with what we have already. So let me start off and log into Bluemix. Okay, let's start off with one of the boilerplate applications, the NodeRed boilerplate application. Now that we've got the NodeRed sample application up and running, we need to add some services. So the first service I want to add is -DB. Next service I'm adding is Hadoop, basically Big Insights. So not only is the ECG data, is it being synced to cloud and then being pushed onto -DB, I also want to push it onto the Hadoop FS. So I'm adding IBM Analytics for Hadoop service as well to my NodeRed project. Okay, next I want to add another service. I'm going to bind actually to an Internet of Things. Okay, let's open up the NodeRed editor. Let's start wiring things together. Okay, first thing is our Internet of Things service. If we open it, connect it to the backend Blue service. It's a device event. The device type, heart monitor. Device ID, we want all connected device IDs. And the event is, in this one, it's a beat. The format is JSON. And this is JS. Let's just give us a name on that. So okay. It's always good to actually put a debug. Close the door. Okay, it's always good to put a debug note, just to make sure that the beats are getting captured correctly. Next one. Okay, first thing we do, let's deploy this and just make sure that our mobile device is sending data. So the mobile device is running on, I use an emulator called Genymotion. I've dragged and dropped. What you can do is, if you drag and drop from Finder, if you drag and drop the APK file that I've sent, it's normally under the folder inside this, the APK file. In this folder here I will give the latest updates, so I updated it today. So you can drag and drop this onto Genymotion and it will install the application here. So this is the mobile application. The bit I need to sort of, you need to connect is this is new. So the IoT sync, you can enable or disable this. If this is disabled, then it won't send any, each time there's a heartbeat, it won't send the information to the Bluemix IoT service. The organization ID, pretty much all of this information you're going to get when you connect from your dashboard. When you launch your Internet of Things service, we can see here when I added a device, I created a new device type called Heart Monitor. The device ID I'm giving is, in my case, I'm giving a phone number, my phone number. Later on in the demo, I'll show you why I'm using the phone number for the device ID. Next thing I do is then I add an API key. The API key is used in the Android application. It's used by MQTT to communicate. In a production like environment, each device added would have its own API key, which we can revoke when we want to stop the application communicating. So every device will have its own API key. When you create a new API key, the key and the authorization token, you should take note of these because it's this key and token is used. This is the API key, okay, and the token. These are filled in here. So these need to be set up between your Internet of Things service from here and the settings, the cloud settings in the application. The device ID, that needs to match as well. Be very careful that this device matches the device ID here. What else is there? The organization ID, you can see here, that comes from here. Oh, in my case it's OPTTFS. That's pretty much it. So just show you again where you get this from. Menu, Cloud Sync. Organization ID, device type, device ID, which is, as you can see in the background, is through the Internet of Things service. The API key, which is you add it here. When you add an API key, with the API key, and of course the token. This is the authorization token. Okay, when this is running, this is to do a test. If you do a test record. Now sometimes this may crash. If it crashes the first time, then restart it again. So we can see each time there's a beat. If we go to our devices, we can see, okay, that this is working correctly. You should be able to see when the last event comes. In NodeRed here, if we go to debug, let's see, yeah, we can see that the objects are coming in. Okay, so we can see that this bit, the first bit, is working nicely for us. So let's just stop that. Disconnect. Hi. Okay. So let's go into more details on the NodeRed and what needs to get wired. Now, to help the instructors and help people with this, we can see the URL in here. So insight2014.mybluemix.net. For all the instructors, when you connect to that, it is username and password protected. But if you speak to me nicely, I will give you the username password, and then when you connect, you can then see the details and basically replicate this within your own NodeRed project by selecting the nodes here, all of the nodes. You can export and save them. Export to clipboard, and then you can copy paste that and push it into your own project. Okay, but I'll go through what I'm trying to do here. So the first thing is we've seen this. So this is connected to my Internet of Things service. On the device ID and on the device type, I'm filtering for anything that's a heart monitor. I'm literally taking all of the heartbeats from all of the connected devices. I'm writing. Basically, this is incorrect. I need to just write directly here to Cloudant. Yeah. So tidy this up. Okay. I wanted to write to Hadoop. So when I connect it here, this node is bound to this service here. So initially, when you've created your NodeRed project, you've added these services. So the IBM Analytics for Hadoop reflects this. Now, when I write to the HDFS previously to it, I wanted to I gave it a directory name, and the actual file I write to, I'm actually using the device ID. So I'll show this later. Into Cloudant, the database I'm giving is HMBs. This is a second thing that I'm doing. What I'm trying to do is just show how in my application I've added another menu here called emergency. So if somebody has a chest pain, they can send, when they send a particular message, do this again. I just give the patient ID number, which is their telephone number, the location. Let me just change the location. Cork, Ireland. Let's send chest pain. Okay, and we can see that this sends the patient ID and the GPS locations. What we wanted to I've added another service here, Twilio. If I add my phone number, 674653809, if we wire it up, I use a formula here to basically formulate the message. Patient ID, device ID, at location, in location, it's got a chest pain. Okay, so let me, now it's wired up, I deploy it. Okay, so let's test out. So if somebody has a chest pain from here, We send a message. That message, the payload comes through here. We formulate the SMS message. We're using Twilio. It's got my phone number here that sends it. Okay, so you should be able to see. Yeah, the SMS messages come through, and there it basically gives the SMS message here. Patient ID, whatever. Okay, that's just an example of how I'm integrating with Twilio. Okay, let's have a look at what's getting written to Hadoop. So let's go back to our dashboard. Let's open up Hadoop. So my colleague Paul Reeves, he's working on the SPSS part. So we can then start actually within SPSS start maybe contacting and connecting directly to HDFS with the files and doing some analysis. So I'm looking for help from our SPSS experts on the back end, so we can start using things like Cognos to basically start looking at the files. So at the moment, this is our Hadoop service. We could see from NodeRed that all beats coming through this stream here, we were creating a file name, a function to create a file name. The file name I was giving it was metal24 plus the device ID, and I'm appending all of the beat information, each single beat from all of the devices. I'm splitting them up and I'm putting them into Hadoop. So if you open user, users, you can see here the directory. It creates a directory that doesn't exist. You don't have to create this. Okay, now that it's wired, let's start streaming. Okay, so the beats are coming through, and we should be writing it out to HDFS. Let's go back to here. Let's do a refresh. Okay, we can see a file has been created here. This file then has, I've added more information as well to what's being captured in each beat, the mean, normal, location, all of this information. All of this is actually being captured by the mobile device. So everything pretty much you see here, each time there's a PVC, which is an irregularity. It's measuring this QRSTA. All of these are cardiology specific parameters being recorded, and all of this is being stored in this file. So imagine if we had hundreds, thousands of different devices, there would be a separate entry here identified by the actual device ID, which in this demo I'm using the telephone number of each device to uniquely identify the device. Okay, so this is something new. This has been added. I've added this the last few days. Okay, the next bit I want to talk about is how do we okay, remember here in NodeRed we're pushing each heartbeat from all of the devices into Cloudant. We spoke previously about how we pushed it into Hadoop, but I'm also pushing it into Cloudant. And one of the reasons I'm pushing it into Cloudant is within DashDB there is a facility to do a synchronization from the document database Cloudant, or the NoSQL database Cloudant, and then to actually create a schema and a table within DashDB. And then I'm connecting then to DashDB through from RStudio. So let me go into some details in that. So what you'll need from Bluemix when you look at your NodeRed project, what you'll need here from Cloudant are the URL for the database, the username and the password. So if we go into -db, so -db, if we look at the way you launch -db is within, I mean, we added it as a service to our NodeRed project. There's a launch button when you select the service, and it takes you here. Now the look and feel has changed a bit. -db was one of the big announcements at Insight 2014. So what we do here is, so when you log in from Bluemix to -db, if you go on the side here on manage, there's this ability to sync from Cloudant. So just when you select the source, this information here comes from Bluemix, and if you do show credentials in your Cloudant database, you get the URL, username and password. So this is the URL. Now, something that's quite tricky sometimes for people first time to using this is that the database name, you need to append the database name. So you get the URL from the Cloudant credentials within Bluemix. But the database name here, I'm calling it beat-hb2, and this database name was created, if you remember, within NodeRed. So within NodeRed, whatever name I give here, if I, for example, if I call it database 3, and I deploy it, when I start streaming data, heartbeats in here, if the database doesn't exist on Cloudant, it will create it. It will create a database called beat_hd3. So let's have a look in Cloudant, for example. We see these are the list of databases that exist already. If I run my Android application, let's run a test record. So within NodeRed, you can see here are my objects coming in. They're getting pushed to Cloudant. So within Cloudant, if we do a refresh, then we can see here that this database has been created. So BH. So this value then within -db, when we're syncing from Cloudant, we take the Cloudant URL and we add it here. This is the database, this is the username. This is then the table name prefix. This is then used as the database name. So when we do a start sync, we can see here the data sync from Cloudant. The first thing it does is create the tables, and then the data sync is in progress. So this is doing a constant sync. So here we see the newly created table. This is the table definition. And if we browse the data, syncing the data now, we can see, we should be able to see, the screen resolution isn't too well. We can see here it's syncing all of these. So from the Android phone, each time one of these is correctly identified as a correct beat, MQTT is taking information, a whole load of information about each particular beat. It's using MQTT to send it to an Internet of Things service. The Internet of Things service, this is capturing it here, is then fanning it out into two different streams, or three different streams. One is a debug stream. One is sending it to Hadoop, is creating for each device that's coming in here. It's creating. It has a separate file, and it's appending each of these records to the file. It's also sending it to a Cloudant database. Within DB, we've taken a document or an OSQL type database. We're doing a sync that we've managed from here. And the first time you do a sync, it creates a standard SQL schema, and it's syncing the data, so it keeps adding to this. Well done for sticking with it this far. So the final bit I want to talk about is the bit we did using the this open source R is a programming language, a statistical programming language, and there is an open source package called HRV, heart rate variability, and so we're trying to use this particular package. We're using something called RStudio. This is RStudio. I have made available a project. I've put it on up on DevOps. You can see here it's under my name, Dan O'Riordan, BDA-Shiny-R HRV. So the source code for this RStudio Shiny project is there. So download it. Open it up. So do File, Open Project, and you'll find it in the zip file when you do a clone from my GitHub repository on DevOps services. If it's your first time, and if you don't know anything about Shiny, then have a look at RStudio. There's some nice tutorials. It's quite an interesting approach, a programming language. It's using something that they call reactive programming, where you have a UI side, which is represented here in the UI R, and a backend called server.r. And literally, when you from within a web page, when you make some changes to some of the input components, that fires a trigger and causes some code to be run on the server.r side. The main thing to know here is how do we connect with the DB database, because the actual database that I use behind this is DB. So when I run the application, this is what it looks like. Now I still have a lot of work to do on this. So we can see these patient records. All of this is coming from the DB database. When you're doing a demo of this, you have to select the tabs from left to right. And due to the way this reactive programming works, I have put some code in here and then in here that needs to get called firstly before some of these the algorithms that get run here. I'll fix this at a later date. But you get the general idea. The idea is that we use some of this this analytics based on the data that's sitting in DB. Later we will look at maybe doing some SPSS analytics. Some of my colleagues hopefully will help me out to do some of the SPSS predictive analytics. But you get the general idea. We have, we're using at the moment we're using DB as the data store behind it. So the main thing to look at and figure out how you get connected from the Shiny application to DB is here. I'm using a library called GDBC. This initializes the DB2 connection using this jar file, this DB2 connector. That's included with the project that you download from my DevOps project. I say what the database is. This, of course, I've got from the credentials within Bluemix. If you look at here, this is the URI here, or sorry, the JDBC curl. Yeah, so that's, this information comes from there. The username and password, once again, it comes from the credentials within the DashDB service within Bluemix. You can see these values here. This is the function called return patient details. Calls this function. So we connect. I do a query, standard SQL query, select this information here from the database where the device ID is like this. I should probably change this to beats3 because I've created a new table within DashDB. Okay, so that's pretty much it. As I continue to improve on this project, I'll post some more videos with updates. But thanks for your time, and of course, any questions, feel free to contact me on Twitter at Dan O'Riordan, or if you're within IBM, you have my email, O'Riordan@fr.ibm.com. Thank you.